All right, Chapter 7 starts on page 269 in the book. Just so you know, I'm going to go over Chapter 7 right now. When we get done, I'll go over the review questions at the end. I forgot to email you the test review document that I've been sending you, so I'll send that during your break. We'll go over that after the break, and then we're going to write a simple program as a class. All right? I'm hoping to be able to get all that done by no later than 10:30, so you have at least an hour of lab today. Tomorrow, when you come in, I'm going to go over Chapter 8. First thing, we should be able to do that ideally in about an hour. Same kind of thing. We'll go over the chapter. We will do the review questions, and then we'll do the test review. Then the rest of the period will be lab. Thursday, when you come in here, we will do the written test for Chapter 8, and the rest of the period will be lab. Friday, remember, I will not be here. All right, I'm taking the students to the Skills USA competition, all right, in St. Louis. So, or 4 of the second-year students I'm taking there. So it'll be lab. Mr. Corrigan will probably have that door open. He will still take attendance, so if you're not here, you're not here. All right. And then next week on Monday when you come in, you will take the Chapter 8 written test, and the rest of the period will be lab. And then Tuesday of next week, all right, you will take the hands-on test for Chapters 6, 7, and 8. I'll try to give you a review or a pre-test before that, all right, just so you have an idea as far as what's going on. So for Chapter 7, I don't want to read to you. But what we're going to do now is we're going to, you've been doing this somewhat, but from now on, a couple things. First of all, we're gonna minimize the number of global variables that you have. When you have global variables, what that means is that any routine can change the value of the variable, even routines that shouldn't. All right? And when you think about it, it's kind of the way life works. In other words, me working here at Rankin and being an IT instructor, I have the ability to go in and take a look at all of your grades for this class. I have no idea how Matthew might be doing in his gen eds, and I don't care. It's none of my business. All right? So there's kind of a separation of things. And it's the same way here. I mean, if I really liked, I like Matthew, but if I really liked him and I had the ability to do that, I could say, you know what, he got a B in that class. He probably should have had an A in his gen ed, and I could change it. They don't want that to happen. All right? That would be an unintended side effect. And if you need another example, it's like I can go and look at certain things in Inside Rankin. I can look at my own information. I can bring up my own W-2s and all that kind of stuff, but I can't bring up, for example, Mr. Corrigan's W-2s. I'd like to, all right, but I'm not able to do that. I can't bring up Mr. Schaefer-Cotter's or Mr. Knott's. I'd like to do that too, but I can't, all right? So what we're going to do then is we're going to minimize the number of global variables we have. If we've got a program that has, for example, an array in it, like we've been using in the last chapter, that can be global because you're typically going to use the array in a lot of different routines. But we're going to write a program after our next break or so where we're going to use absolutely no global variables whatsoever. All right? So we'll learn about methods and implementation hiding. You may or may not have heard of that term before. All right, it's also known as black box mentality. In other words, if you were to open up the inside of your computer, there is literally a CPU in your computer that's about the size of a postage stamp, and that's what makes the computer go. However, and I've shown you this before, when I do a Control P, all right, and I tell it to print, maybe it's not going to print, but I have no idea what happens when between the time I hit Control P and hit enter and the time it comes out of the computer. That's hidden from me, all right? So implementation is the stuff inside that makes it go. What we've been doing is we've been creating interfaces. We've been writing some of the implementation, but we've been creating interfaces. All right, so we'll write methods that have no parameters and no return value. If it has no return value, remember the return type is void. right? We'll write methods that require a single argument, so one thing in the parentheses. Write methods that have multiple things in the parentheses that returns a value. You can return anything. An int, a double, a Boolean, all right, a char, a string, an object that we'll look at in the next couple chapters, 9 and 10. We'll talk about passing an array to a method. They go through some of the different ways that you can write main. We've been writing main in a certain way so far, but it's possible to write it in other ways. And we'll look at that. And then, as always, talk about some of the problems doing this in a GUI. What I'm going to do, again, after the break, is we're going to write a program. I purposely didn't, the program works and it's complete. It's a console program. It's very simple. All right, there's enough to type because there's about 70 or 80 lines you've got to type. But I'll put them up there. All right, so you can do this. But what I'd like you to do, and you don't have to turn this in, but is to go into that program and do two things. First of all, I didn't set it up with try-parse, and I want you to do that. And second of all, I want you to see during your own time if you can take that particular program and convert it from a console into a GUI. If you can do that and you understand everything you're doing, you should be in pretty good shape to take the next test. All right? So a method is, it says it's an encapsulated series of statements that carry out a task. All right? And, again, when people hear encapsulated, they get confused. And I'm not going to bring it up, but it's like the example that I showed you before in an earlier class. I bring up a calculator, I put in a number, 346. Hit the square root key, and boom, it gives me the square root of 346. The way that that's done is there's a method inside of that calculator to do that. But it's encapsulated or hidden from me. I don't know how it works. I really don't care how it works. I just care that it gives me the right number. All right? When you write your own methods, you have to invoke or call those methods. I will tell you that by and large, any word that she puts in here that's bolded will probably make its way onto your written test. All right? So they give an example here. Main is something we've been using. Okay? This would be kind of a silly program because all it would do every time you ran it would be to write hello on the screen. But you get the idea. Main is the name of the method. All right? It doesn't return anything, so its return type is void. And it's static, which means that we can, it's to try to keep it simple. There's one of them, and there's certain ways that it can be called, certain ways that it must be called. You're going to see that later on in the chapter. All right, so they talk about implementation hiding in here, and it says write line is an example of implementation hiding. I don't know about you, but internally in the computer, I don't know how write line works. Even something as simple as what we just saw. I don't know what makes that magic happen. I don't care. Okay? That's its implementation, and that implementation is hidden from me. Again, they sometimes refer to it as the black box mentality. All right, and it's funny that they call it the black box because, I see you all have black computers, and so do I. But today, geez, I watched my wife watches that home shopping thing, and the ones that sell out last are always the black ones. It's always the pink ones and the, chartreuse or whatever the hell, that they make that people want today. All right. So it says creating a method instead of writing 3 lines is useful for 2 reasons. So why do you create methods? There's 2 main reasons that you do. One reason is it makes those methods reusable. So you can call them again and again and again. So imagine that I was doing a payroll program and all of you worked at a place. So there's 8 of you. All right? Now, pretend we didn't even know about arrays. We don't care about arrays. All right? So I have, first employee, second employee, third employee. If I have to sit there and say for each employee, let's assume there's no overtime, but would I really want to write in there 8 times gross equals hours times rate? I don't want to do that if I don't have to. All right? I want to write a routine and call that routine 8 times. All right? So it results in less code, and it makes main easier to follow. Main is just a driver then. And it avoids what's called code bloat. When you've got code bloat, what that means is you're putting in more code than you need to put in. All right? So it says figure 7.2 shows the parts of a C# method. Let's look. All right? So that's everything that's in there. These are all the things that you have to eventually know, somehow commit to memory. This can be private, this can be public, this can be protected. We talk about that more in chapters 9 and 10. This is a static modifier. We'll talk about that more in just a few minutes. Void means it returns nothing. Show welcome messages is the name of the method. Open and close set of parens with nothing inside means nothing is being passed to that method. There's no information that it needs. Everything between the curly braces is the method body. All right? It is possible to write a method that has no body. In other words, you can write a method that just has an open and closed curly brace, but it doesn't do anything. I don't know why you would do that, but there's nothing to stop you from doing. All right. It says the optional declared accessibility for a method sets the limits on how other methods use it. And it says it'll be in the table that's right here. Now, again, I would not commit this to memory, but you are asked about accessibility on your next test. I guarantee it. So again, public, protected, and private. Don't worry about the internal stuff right now. We go into that more in chapters 9 and 10. But if it's public, that means that it's available to everybody, to your program and into any other program that might come in contact with your program. Anything that's public. Private means it's just within your program. Protected we'll talk about in chapters 9 and 10. Again, not my intention to confuse you right here. All right. Let's talk about static. Okay? It says if you use the keyword modifier static, you indicate that a method can be called without referring to an object. Since we haven't talked about objects yet, virtually everything that we've done has been, especially in console apps, we've either put it right in main or had main call something. But in directly or indirectly, everything that we've done has touched main. So everything that we've done has had to be static. Now, you may not like that definition. It may not work for you. It may not mean a hell of a lot. But again, that's what chapters 9 and 10 are about. And we will go through 9 and 10 beginning around Wednesday of next week. All right? So when you've got a static method, it needs to be called with a class name. A non-static may be called with it or without it. And you might say, well, I haven't done that. You have. You just don't know that you've been doing it. All right. As it says, when we get into chapters 9 and 10, ideally at least, the use of static and non-static will become clearer. If we get into 9 and 10, and you're like, I still don't have a flaming clue as to what any of this means, you have to ask. All right? All right. Every method has a return type. The return type might be void, which means there doesn't have to be a return statement in there. But it can be any type. If you return something, it's known as a value returning method. All right? And it says here the stuff that you put in the parentheses is called the parameter list. Yeah, that's fine. Again, you can look at this and you can tell by looking at it that main does not return anything. And since main does not return anything, what that literally means is that the method type is void. It must be, because there's no return statement in there. Also, you can tell main does not take any parameters because there's an empty set of parentheses in there. Now, if we look at this, here, main is calling another method. Main is calling a method called show welcome message. So rather than us putting these 3 lines right inside of main, all right, we're calling that from main. So notice how this prints out. We call show welcome message, so control of the program goes to here. It writes welcome, it writes have fun, it writes enjoy the program, each on their own line because it's a write line. It hits that curly brace, it goes back here, and then it writes hello. All right, so understand the order. Prints that first, prints that second, prints that third, prints that fourth. When you declare variables inside of a method, they're known as being local to that method. It means they're only known within that method. The majority of the variables that we create from now on will be local variables. Not all of them. Sometimes there's good reason not to. All right, and in 9 and 10, we'll create a lot of variables that won't be local because we'll be working with objects. So if you look at the example in here, it's actually a fairly decent example. Notice that in main, we create a variable called A. And we say in main, A is, and it says 12. Exactly what you'd think. Then we call method with its own A. And we create a brand new A that's got a value of 354. And it says in method, A is 354. But then when you get back, it says in main, A is 12. Because those are 2 different variables. They just happen to have the same name. All right. Not a great example, but at Wentzville, Rankin Technical College, there is a Jeff Scott. At Rankin Technical College in St. Louis, there is a Jeff Scott. All right. So again, when you go through this, and ideally you'll take a few minutes and read this, if it doesn't make a lot of sense to you, I would strongly suggest you go through the You Do It's. There's one on 279 and 280. Again, with those programs, the author tells you exactly what to key in and shows you exactly what your inputs are and shows you exactly what your outputs should be. So if you're having a hard time understanding this stuff, it's in your best interest to go through the examples. All right, page 281, writing methods that require a single argument. So when we look at this example that's right here, this says, hopefully what I'm about to read to here about the blue stuff here makes sense to you. First of all, the access modifier is private, so it's only known within the class that uses it. That's the first thing. Second thing, it's static. All right? Again, don't worry so much about static right now. Third thing, it's void, meaning it does not return anything. Fourth thing, display sales tax is the name of the method. Fifth thing, when you call this method, you must pass into it a double that will be referred to in the routine as sale amount. If you understand that, there isn't any more to understand. All right? Now, this gets a little bit hinky, for lack of better words. Let's see if they show some code here. Good. All right. Right here, we're creating a variable. That variable is called myPurchase, and we're both declaring a variable and initializing it. Does that make sense to everybody? All right. That variable is called an actual parameter. That's its actual name. Then we pass it to a thing called display sales tax. All right, and we pass it in as myPurchase. Now it's been renamed sale amount. So this variable right here is called an actual parameter that we're using here. Inside of here, it's called a formal parameter. All right, it's kind of like, look at it, that if you've got a name and a nickname, people can refer you as either one. All right, but actual parameter where it's declared. Formal parameter is its name inside of the method where it's used. Okay? Now notice that we're passing this, and we're passing the actual parameter. We couldn't pass this. We could not take sale amount and put that in here. If we tried to do that, we'd get an error because we've never declared a variable in this routine called sale amount. We can put a literal into it if we want to. All right? But that 35.67 inside of this routine is now referred to as sale amount. That $12.99 that's my purchase in this routine is now referred to as sale amount. All right? And if you get that, you're on your way to understanding this. Okay? Sometimes people look at that and they go, I understand, I do. But why don't we just throw everything in one frickin' method? Because then that one frickin' method gets really, really huge. All right? In an ideal world, every time you write a method, you should be able to view the entire method on one screen, which means that each method ideally should be around 20 lines. Do people break those rules? All the time. But if you do that, it makes it much easier when you can see the entire method at one time. All right? Now, I guess I jumped over that, but at the bottom of the page there, the author says, this was back in Chapter 2, that if I call a routine like this that expects a double, and let's say in here this had just been the number 12. So it's not 12.00, let's just say it was int my purchase equal this type of thing. Okay? And then we would have passed it in here. The system would have converted it from 12 to 12.00. It does automatic conversions for you, as shown on the bottom of page 282 and the top of page bottom of 283 and the top of page 284. All right? Sometimes when you write methods, they require multiple arguments. That's what we're going to do. We're writing the world's simplest, dumbest calculator. All right? That's what we're going to write after the break. And we're going to pass in two numbers. So I pass in 34 and I pass in 6. And it'll come back and say 34 plus 6 is 40, 34 minus 6 is 28, 34 times 6 is 204, 34 divided by 6 is like 5 point whatever. Get the idea? That's what we're going to do. All right? And the program itself is piddly. It doesn't matter very much, but the reason that we're doing that is to try and go through so you can see how stuff is called, how stuff gets returned, etc. Now, you can pass multiple arguments to a method. So you can pass 0, 1, or more arguments to a method. And it even gets a little bit, what you'll see not in this chapter, but when we go through chapter 8 tomorrow, it gets a little bit weird. Because let's say that I was doing a program right here and I was passing in three things. Three things. A first name, a last name, and a state. Everybody with me? All right, so those would be the three parameters. I could sit there and when I did this, I'm going to just bring this up. This is what we'll do tomorrow, but I just want to show it to you now. So if we had this, and we wanted to put in something like this, private, static, void, display, I'll just call it that. And we said string, first name, string, last name, string. We can say this, S equals, all right, and if we do that, what that says is we can call this and pass it a first name and a last name and a state, but if we only pass it a first name and a last name, default the state to Missouri. So we'll talk about what are referred to as default parameters tomorrow. All right, for now we don't care about that as much. Now, one thing that the system needs is if I call this from main, everybody with me right here? If I call this from main, so right up above this line, I've got a line that calls display sales tax. And I put in there true, comma, false. The program will blow up because it's expecting two numbers and I'm giving it two Booleans. All right? So the system goes and it checks to make sure that what you pass and what you declare are compatible. And it also checks to make sure that they're the same number. If I pass 5 things up here and I only account for 2 of them here, I'm going to get an error message. There's a lot of ways that you can screw this up, either intentionally or non-intentionally. All right. Just so you know this, the maximum number of things you can return from a method is 1. Everybody hear that? The maximum number of things that you return is 1. So you return either 0 things or 1 thing. But that 1 thing can be an array that has 1,000,000 elements in it. You can do that. All right? That 1 thing can be an object that we'll go over in Chapter 9 and in Chapter 10. So notice here, we're saying that we're returning a double right there. If you say that you're returning a double right there and you don't put in a return statement, you get an error. If this is not void right here and you don't have a return, you get an error. In addition, whatever you're returning here must be that type. So if I said here return true, I'd get an error. It's expecting to return a double, I'd be trying to return a Boolean. The system does that coordination to make sure that if it's looking for something, that's what you give it. All right? And if you don't, you get an error message. The good news is typically you get an error message right there, and it pretty much shows you exactly what the problem is. You use a return statement to return a value. Okay? Here's an example here of this program that's on, I don't know, page 287. All right? So we're saying here, and this is very similar to the stuff we've done, gross pay equal calc pay, and you're passing in hours and rate. Hours and rate. Now in this case, it's my hours and my rate, and here it's hours and rate. These are the actual parameter names. These are the formal parameter names. We could have called this my hours and my rate just like we did up here. They can be the same thing, but they don't have to be. All right?
What's the benefit of making it a different name?
Okay, the question was, what is the benefit of making it a different name? It's a good question. Imagine that instead of this, I'm going to just change this to this. I'm going to write my own method here. I'm going to say private double add 2. All right, we'll say double number 1, double number 2. And we're just going to literally say return n1 plus n2. Okay? Now I can call that from up above, and I can say int, or not int, double A equals 7.3, double B equals 6.2. Then I can say add 2 A, B. Well, what if up above I said double X equals 9.7, double Y equals 10.8, add 2 X, Y. So you give it different names, so if you call it multiple times, all right, you've got generic names, and that's what most programmers do. Plus, sometimes you've got a very long name here, and then you make it in here a very short name. All right? But there is nothing that stops you, if you really want to, from always calling your actual parameters and your formal parameters, especially if they're only called once. Now, I'm not going through this example in here just because of the fact that we've already done that payroll program, so I don't really see the need, all right, to go through these payroll examples. All right? Now, guess what? You've done this too. Correct? You've done stuff that looks like this in the blue. You've already nested method calls. So what the system does is it says, grab readline, run that first because it's in the innermost set of parentheses. Use the output of readline as the input to convert to int32. Then it says use the output of that as the input into get price. All right, so that's actually got 3 levels that are in there. There is no limit to the number of nestings that you can do. I don't know if I ever told you my story about this, because I got a weird sense of humor, I'll admit that, but I found this hilarious. I worked with a guy when I was at AT&T named Andy. He was brilliant. All right, he had his doctorate already, and when he started there, he was like 22, and he already had his doctorate. I mean, the kid was smart. So what he did was he wrote all his code, and he nested stuff 15 or 16 layers deep. And no one could understand it except Andy. Okay? And Andy still lived at home. And then Andy quit. And nobody could figure out his code because of the way he wrote it. He took a job across the street from AT&T with people who did outsourcing, and AT&T hired him back in. All right? And because he's the only one who understood his code, and they almost doubled what he was making, but they didn't give him any benefits. He didn't care because he was still living at home. All right? So don't think people don't do things like that. All right? It's kind of harder to do it today, but you hear about stuff like that happening. All right, you can return anything, including a Boolean, so you can return true or false, as an example. Not only can you write your own methods, but as mentioned on page 289, you can use built-in methods. You've already done some of this. WriteLine is a built-in method. Convert.toInt32 is a built-in method. ReadLine is a built-in method. All right? So they give an example right here that says this. This is the same thing as saying 2 cubed, just so you know. You're going to get back 8. So from this statement, it says you know the following. It's part of the math class because it's math dot. So the name of the class is math. The name of the method is POW. POW, short for power. All right? It's public. All right? Because anybody can use it. It's static because it's used with the name of the class. I don't have to create an object. Look at static right now as meaning we don't have to create an object. When we get to chapters 9 and 10, we will be creating objects. And guess what? We'll be creating a payroll object when we start. So it's something that you've got some familiarity with. We can tell that it accepts 2 doubles. Since it accepts 2 doubles, it's going to also return a double. All right? And that's all the author is saying in there, is you can look at what's built in and oftentimes figure out how it's used. Again, on pages 290, 291, and 292, there is yet another you do it thing. All right? I'm trying to really, when we get into here, you may or may not agree with this, but I'm trying to give you an hour and a half of lab today. I'm trying to give you about 3 hours of lab, or maybe 2 to 3 hours tomorrow. All right? I'm trying to give you Thursday, basically almost 3.5 hours, and Friday, the entire period. So if you say, I don't get this stuff, then you should be going into the book and looking at the you-do-its. Typically, they're only a couple pages long. You might have to type in 20 or 30 lines. But I think it'll really help your understanding. At least that's the hope. All right. 293. If you pass a single array element, an element, into a method. So if all you pass in is an element, it's just a variable. So it's like if I have 10 test grades that are in an array, and I just pass in test sub 3. That's just gonna, if that's a 71, it just passes that in. It gets passed in by what's called pass by value. We'll talk about that tomorrow. Tomorrow you'll learn the difference between pass by value and pass by reference. All right? If, on the other hand, you pass an entire array into a program, it's passed by reference. What the big thing there means is if you pass an array into a program, if you pass an entire array into a program, and you change anything in the array, it's a permanent change. That's really important. And again, that's the subject of tomorrow. So you don't have to worry about it for right now. But that's called passing it by reference. Not only that, when you do it, see what you have to do? You have to say int bracket bracket so the system knows that it's an array. If you left the brackets out, it would think you're passing in just one value rather than an array of values. So that's just part of the syntax for the language. You don't put a number in there. All right, you don't have to. You shouldn't ever put a number in there. You probably will get an error message if you do. It gets even hinkier when you've got multi-dimension arrays, because notice what you need: bracket, 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 bracket. If I had an array of 6 dimensions, it would be bracket, 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 bracket. All right, which is totally legit. All right, we only have about 5 more pages. Alternate ways to write main. You've always written main like this. In fact, if we look, I'm just going to show you, this is the program we'll be working on after the break. We've always had this. Okay? You can write main a lot of different ways. This means that main, right there, doesn't need an object to call it. It returns nothing. Its name is main. And if we want to, we can pass in an array of strings, and each element in that array is called args. So it's args0, args1, args2, etc. But there are other ways that we can write this if we want to. All right? Let's see if they show it in here. Oh. All right, I'll show it to you like this. So right now, what they're saying is that's how you write main. And I'm going to put this in a comment, but we can also write main as static int main paren paren. You can do that, which means that main doesn't require anything and it will return an integer. Why would you do that? They do that because the C# language, in some ways at least, okay, is taken from the C language. And that's how you write a main in the C language. Except in the C language, everything is lowercase. Okay? That won't work in this language, but you can do that. If you do that, then at the bottom of your main, you've got to say return followed by an integer. So why would people do that? If you're writing code that's always returning something if it worked, or not returning one value if it worked and returning another value if it didn't work, then that's typically how you'd write it. All right? And in a C language, you typically would return 0 at the end. And 0 just means, hey, everything worked the way that I thought it would. That's all it means. They also talk about writing main with public access. You should never do that. All right? I mean, it's one of those things where they're saying, hey, you can do this. Yeah. You know, and watching here, one of the things I'm constantly amazed at, you know, whether I'm in Wisconsin or whether I'm in Illinois or whether I'm in Missouri, is people drive like assholes. They just do. You know, 70 is the perfect example. You know, especially when you get close to the Rankin campus that's in St. Louis. Yeah, if you're there and you're doing 60 in the 60 zone, you're going to have people beeping at you and they're going to be crawling up your butt and everything else. All right? And just because people should do things a certain way doesn't mean they do. All right? So there's a lot of rules in here that you should follow. Sometimes you can get away with not following them. All right? Whether that's a good thing or a bad thing. All right? All right, so finally the chapter ends on pages 299 and 300 by talking about problems with main and GUI programs. I'll show you what the biggest problem is. And that is you don't even see main in a GUI program. It's in your application start. It does everything for you, but it's encapsulated or hidden from you. All right, because that stuff is just done behind the scenes for you. In here, we have to do it. That is the biggest issue. It says, understand methods that are automatically generated by the visual environment. Well, again, you know this. If you've got a button called OK button and you double click on it, you're going to get something that looks like this. That's going to be created for you automatically. All right, again, that shouldn't be a big thing. On 300, they talk about appreciating scope. Again, you should always strive to make everything you can possibly make, local and not global. The number of global variables that you ever have in a program should be as minimal as you can make it. Because if you do that, then the only routines that can change it are the routines that have that routine where it's been declared. Or as you'll see tomorrow when we start calling routines from routines. All right? So that's it. If you would please, before we take another break, let's turn to page 303 and let's look quickly at the review questions on page 303. Then we'll take a break. During the break, I have got to email you the test review page for Chapter 7. Maybe I'll find the one for 7 and the one for 8 and just do them both right away. All right? So, review question number 1. At most, a class can contain, number 1 is D, any number of methods. It's not that you're limited to 0, 1, or 2. So number 1 is D. In fact, so is number 2. They're both D. Number 1 is D because it's any number of methods. Number 2 is because methods are easily reusable. Main becomes more detailed. Because all methods must be stored in the same class, they're easier to find. All right? Turning the page. Number 3. So numbers 1 and 2 are both D. Number 3. In C#, a message must include all of the following except. The answer is actually C. You don't need a body. You can have just curly braces. So number 3 is C. Number 4, a method declaration might contain a declared accessibility. All right? In fact, I wouldn't even say that. I think that's the answer to the next one. Okay? I'm not even sure what they want for 4. It's A or B, but I don't know which one. And I don't care. They never put that on a test. I'm throwing it out anyway. All right. Number 5. I'm sorry. That was number 5. Every method declaration must return D, a return type. Void if it's not returning anything. I think 4 is A. 5 is definitely D. Number 6. If you want to create a method that other methods in other classes can access, you make it public. You've already seen a lot of stuff with public in here. Number 7. If you use the static modifier, the keyword modifier static, in a method header, you indicate that the method D is called without an object reference. That's what we've been doing so far. Number 8, a method's type is also known as its, I think it's B, accessibility. Again, that's a really badly worded question. Number 9, when you use a method, you do not need to know how it operates internally. This, again, is an example of C, implementation hiding. So 9 is C. Number 10, when you write the method declaration for a method that can receive a parameter, you need to include all of the following except D, an initial value for the parameter. Anybody need any of those first 10 repeated? All right, then let's go on. Number 11. Assume that you have a variable as int my age equal 21. Which of the following is the correct definition to that? The answer is B. C is invalid. A and C are invalid because you don't pass the type. All right? And D is invalid because it needs a parameter and you haven't given it one. Please, I've said this to you before. When you're taking these tests, maybe you saw this on the test today. A lot of times the instructor, the author will ask a question, then gives you the answer in the next question. All right? She's not trying to trick you here. Number 12, suppose you declared a method named all this stuff. When a method calls it, the calling method, I've got B, might contain a declared double named rate. All right, I don't understand this. I wanted to say it must declare, this. It's A or B, but again, I don't understand her wordage here. Number 13, in the method print the data, double salary. Salary is a formal parameter. So number 13 is A, formal. Number 14, a program contains the method called print the data salary. In here, the name of the formal parameter must be, all right? And the answer is, in this case, it is salary, but it can be C, any legal identifier, all right? But in this case, it depends on how she means that. When she says must be, I guess it sort of sounds like it's salary. All right, does she mean must be or can be? I don't know what she means. Probably if I ever brought her in here, she'd say, you're a nitwit and my questions are fine. You're the one who doesn't understand things. All right, number 15. What is a correct declaration for a method that receives two doubles and displays the difference between them and returns nothing? All right. Notice in this first one, it says double price 1, price 2. It doesn't have a type right there. Everybody see that? So A is illegal. So the answer is B. So number 15 is B. Number 16. What is the correct declaration? Let's keep it simple. They both are correct. So 16 is C. Both of these are correct. 17, as far as I can tell, the answer is D, the one right here. Again, don't really like the way the question was written, but that's how she wrote it. 18, they're talking here about using that short circuit evaluation. Since it's an OR and the first part is true, the answer is A for number 18. Number 19, it's an and the first part is true, so it must check the second part. So the answer for 19 is C. Both methods execute. Finally, and again, this is what we'll talk about tomorrow, when an array is passed to a method, the array is passed by a reference. Anybody need any repeated? Then let's come back at 9:55, and during that interim, I'm going to email you the review sheet for both Chapter 7 and Chapter 8. I'm going to do that right now. Then we'll go over the review sheet for Chapter 7, and then we're going to write some code. All right?